Yes. So we'll continue the last video. So in the Lamis theorem, see the Lamis theorem is nothing but law of sign of forces. Law of sign of forces. There are three different forces, F1, F2, F3. See, are acting at common point. The F1 by sin alpha equal to F2 by sin beta equal to F3 by sin gamma. So these are the forces F1, F2, alpha, beta, gamma are the angles. So this theorem is derived from the law of sines. Sine is the trigonometrical function, you know. So there coplanar forces which are acting. So this Lamis theorem is particularly useful to solve the problems in the mechanics. See, to find out the forces. See, you can resolve the forces, resolution of the forces, and what are the different concurrent forces are acting on the coplanar plane. So those forces can be find out their magnitudes and directions. See, in the Lamis theorem, I told you there are three different forces if you observe here. The first force, let us say Fa. See, Fa is the force which is acting and opposite angle is alpha. Fb is the another force which is the opposite angle is beta. Fc is another force, opposite angle is gamma. So according to the Lamis theorem, Fa by sin alpha is equal to Fb by sin beta is equal to Fc by sin gamma. So this Fa can be resolved into two components, like see horizontal component and vertical component. See, horizontal component is Fax, vertical component is Fay. According to the equilibrium of concurrent forces, algebraic sum of all horizontal forces are is equal to 0. According to the algebraic sum of all vertical forces are also is equal to 0. By using these principles, we can derive this Fa by sin alpha equal to Fb by sin beta equal to Fc by sin gamma. So in this process, for example, if you know the angle between two forces, so if you know the values of Fa is equal to 5 newtons, let us take Fb is equal to 3 newtons. So Fc equal to, you should find out, alpha equal to 30 degrees and beta is equal to 60 degrees. Gamma is equal to, see, some other angle. So based on these angles you can find out, see the magnitude of the forces and the relation between the forces. All this can be find out by using Lamis theorem. See, coming to the next one is free body diagram. This is also important law. There is an important concept in the laws of motion. In the laws of motion, Newton's laws of motion. So the Newton's laws, how it is important, as similarly we have free body diagram. What is FBD? It is it's a visual representation to analyze the forces. See, whether horizontal force or vertical force, where it is acting, all those things, it's a contact force. So all these things are explained in the free body diagram. So in the free body diagram, which analyzes entire system, the concept of the forces, in what direction they are representing and what is their magnitude, and all those things are so clearly explained in this schematic view. That is known as free body diagram. Since force is a vector quantity, so it has magnitude as well as direction. So in the free body diagram, which helps to understand the forces, analyze the forces and their magnitude and as well as directions. So in which crucial solving the problems in the laws of motion. In the free body diagram, so there are some connecting bodies will be there. So something like there is something, so pass over the FBD, there is some pass over the pulley, there is objects which are connected with help of something like this. If an object is there, let us take, there is an object. So the object is here. M1 is the object which is connected with help of a string or rope which is passed over a pulley and is suspended some. So there is another mass M2, M1 and M2. So there is a tension in the string T. So if you draw the free body diagram to do this type of problems, see, in this actually you can understand the object is lying on, M1 is a object which is there on lying on the horizontal surface. M2 is the hanging mass. M1 is the stable, like so it is sitting on the table, but M2 is hanging mass. There is a gravity will be there. If you draw the free body diagram for M2, so there is a M2G, the weight of the free body diagram, M2G. See, M2G is going to act vertically downwards. M2G acts vertically downwards. There is a tension in the string. See, acts vertically upwards. Tension in the string which is going to act vertically upwards. M2G acts vertically downwards. See, there are two different forces are acting. One is, okay, so opposite to others. So if you try to write the equation according to the concurrent forces equation, if it is at rest, so M2G minus tension. Of course, if the body is at rest, so it will be net force is equal to 0. It may not be at rest here because there is a depends upon the masses which is going to be accelerate. That's why the resultant force is M2A. So the equation is M2G minus T is equal to M2, see, M2A. See, mass into acceleration here. So this is called, okay, see, something like net vertical forces are equal to 0. Algebraic net vertical forces are is equal to 0. So this is the diagram. From this diagram I am able to write the equation. Similarly, horizontal, see, object, you take M1. M1 is the horizontal object. Here there is a tension, T is acting, but there is no gravity here because it is lying on the horizontal surface. So that's why you can write the equation T is equal to M1A, because only acceleration due to this mass which is going to be accelerate. So T equal to M1A. So now if you take, there are two equations we got. So in this process you can find the tension in the string and acceleration of the bodies, acceleration of the system. So, and how much force is acting on the pulley, all these things can be found out. These are all possible with help of free body diagrams. So the free body diagram, other important concepts. So what are the steps involved in the free body diagram? If you take the steps, the first we have to identify the object. See, for what body you want to draw the free body diagram, first that you have to identify it. See, that identification is important. Determine the object or system which you want to analyze the forces. Determine the object or system which you want to analyze the forces. See, this is the first statement, important statement. So in that you can take it as, another one is isolate the object. You can, so make it as single object. So in the previous problem I told you there is M1 and M2, but I have drawn only one, okay, see, mass, that is isolating. Isolate the object in the interest of the surroundings. This involves mentally, so you are actually what it is, separating the object from the environment. You are separating object from the environment, and the external effects, external forces acting on, we are neglecting it. So in that way we are isolating the objects. Third one is identify the external forces. So let us say some external forces like friction and other so important forces if they are acting, or gravitational force, contact force, applied force, etc. that all should be considered. So represents with vectors, because force is a vector quantity, at what direction and what magnitude they are going to have. So these are all the things should be taken into consideration. and label the forces with capital letters. So what are the forces? Like tension, T, and F is the force, or see W is nothing but some weight, and T for tension, etc. With capital letters you label the forces. And coordinate system, this is also very important. See, the coordinate system establishes if it is necessary to help the describe the direction of the forces. And last one, we have to include all relevant information. What are the constraint conditions? Any constraint conditions are there? Any length of the string is constant? All those things you have to mention here in the free body diagram. So the friction and other things are also should be taken into consideration. These are the steps should be followed to draw the free body diagrams. So here a person is there, okay, riding a bicycle, okay, so some inclination here. If you observe carefully here, there are how many types of forces are there? See the types of forces, if you observe here, there is a gravitational force, okay, the gravitational force which is there here, which is perpendicular to the surface. So that's why this gravitational force which is going to act, which is perpendicular to the surface, opposite to the gravitational force there is a normal force which is going to be there. And another force you are applying, you are riding a bicycle on the inclination, there is a force is applied here, and opposite to the applied force there is a parallel to the surface there is a force called friction. So the frictional force is also should be taken consideration, and angle of inclination is 30 degrees. So these are all the different forces, okay. See, one is normal force, another is gravitational force, and applied force and frictional force. All these forces you are taken into consideration in the free body diagram. When you draw the free body diagram, you have to consider all these, okay, see, conditions. These conditions are very important. Then only you can draw error free body diagram. Once if you draw free body diagram, it is easy to resolve the forces and make the equations and solve the problems. So this is very important in the case of any inclination. If it is present, inclination is present. So let us take here this is the same object. So the same object, if it is there on the inclination, if the object is here, there is a mass of the object is m, and angle of inclination is theta. So just now I told you there is a weight of the object, so W. See, this is an angle theta again. So this is resolved into two components. The weight is resolved into two components. See, along vertical and horizontal direction. Along vertical and horizontal direction. So that is W cos theta, W sin theta. That all will be discussed in the more clearly in the next videos. So here there is a normal force which is balanced. That normal force, again normal force also resolved into two components. So n cos theta, n sin theta. Frictional force we have to consider. There is a frictional force, contact surface. So contact force which is acting on the surface only. So all these are the different forces we have to take into consideration when you draw the free body diagrams. Yeah. Coming to this, here there is a pulley, object is there on the inclination. If you observe carefully, the object is lying on the, not on the horizontal surface here. Object is lying on inclined surface. There is a inclination is there. The angle of inclination is theta. So there is a m1 is object, the gravitational force m1g is acting vertically downwards. See the component, horizontal component m1g cos theta and m1g sin theta, there are two components will be there. So m1g cos theta is acting in one direction, m2g, so there is another force, see something like hanging mass here. The hanging mass which is going to be there, this is m2g, there is a tension which is balanced. If you draw the free body diagram for m1g, so m1g is acting vertically downwards, opposite to m1g there is a normal force which is going to be there. So that normal force also resolved into two components. m2g is balanced by the tension, there is some acceleration, so you can write m2g minus t is equal to m2a. The equation can be written. So in this way, the free body diagrams which helps to resolve all the see connecting body problems and other wherever it is needed, the resolution of the forces, finding unknown force, unknown angle, etc., angle of inclination. So thank you very much. Thanks for watching the video.